Now that we have our vectors broken up into coordinates, we can do some calculations with them. So let's say we have some vector A, which is defined as this, and a vector B, which is defined as this. The first thing to do is addition. And that's very simple. If you want to add two vectors together, we just add all the components separately. So vector A plus vector B is itself a vector, and the first component is ax plus bx. So you've added together the x components of the two vectors. The y component is the sum of the two y components, ay plus by, and for z it's the sum of the two z components, az plus bz. Very straightforward. And that, it turns out, is equivalent to what we did graphically, which is add them head to tail, or make up a parallelogram. Another thing we might want to do is find the length, find the modulus. So if you have some vector with its x, y and z components, we can use Pythagoras' theorem to work out the length, because you've got a right-angled triangle. The hypotenuse of this is this squared plus that squared equals hypotenuse squared. So in general, if you've got some vector A and you want to find the length of it, also known as the modulus or the strength or the amplitude, remember that's showed that by having two vertical lines on either side, and that will just be the square root of the x component squared plus the y component squared plus the and finally, if you want to find the unit vector, and if you remember, unit vector points in the same direction as the vector but is of length 1, and it's useful for saying which way something points if you don't care about how strong it is. So the unit vector is written with a little cap over the top, and that's just going to be the vector divided by the length. So if the length is bigger than 1, divide by the length, it brings it down to a length of 1. If the length is smaller, dividing will make it smaller. So this is going to be the vector ax, ay, az divided by the magnitude of the vector, which we just worked out up here. You can also multiply vectors by a constant. So for example, 3 times the vector A is just equal to 3 times the x component, 3 times the y component, and 3 times the z component. All pretty easy. And these are the main vector operations we're going to need to calculate electric fields.